Computational thinking is a type of thought which is trying to be facilitated by schools more and more these days. However, there is no definitive definition. Jeanette Wing has come up with a definition which I like, as it summarizes the concept well and allowed me to gain a firmer grasp of the idea myself. Barefoot Computing give a much more simplified definition, saying that computational thinking is learning to think in ways which allow us, as humans, to solve problems more efficiently and, when appropriate, use computers to help us do so. This is quite vague when it comes to definitions. However, they go on to talk about it in much more detail, identifying 6 different concepts involved in computational thinking. These are logic, algorithms, decomposition, abstraction, and evaluation. They also go into 5 approaches needed within computational thinking. These are tinkering, creating, debugging, persevering, and collaborating. This document goes on to say that all of these concepts and approaches, once applied to achieve computational thinking, are designed to help find the most efficient method to solve problems. The national curriculum mentions the use of computational thinking, plus talking about the use of logical reasoning to solve problems through decomposition and debugging. These are all aspects of computational thinking, and their inclusion in the computing curriculum will help teachers to encourage children to think in a computational way. Although time should definitely be put aside for specific teaching of computing, the use of computational thinking should be taught and encouraged through the week. Wing talks about how computational thinking shares aspects with mathematical thinking in solving problems, with scientific thinking, for example when sorting and analysing groupings, and also with engineering thinking, so within a school this would be DT, in designing and evaluating structures. This analytical thinking can definitely be used in these subjects, but it can even branch out to English, as children could compare an instructional piece of writing to an algorithm. Computational thinking also relates to the teaching of systematic synthetic phonics, or SSP. As it says in the title, this teaching is designed to be systematic, as on the whole, when learning phonics, it is taught in a logical way. If children are shown how to use computational thinking beforehand, then the act of learning phonics will become much easier. Brennan and Resnick talk about the device of computational thinking and connect it to the use of the program Scratch. Scratch is a program that allows children to carry out a form of programming, but using blocks which contain commands, which can be connected to create instructions for the on-screen sprite. The logical way that this works is great to get children into programming. As Brennan and Resnick discuss, it incurs a great level of computational thinking. Standard coding, for example with HTML, will also help with computational thinking. However, when it comes to children of primary school age, they will need a program like Scratch to facilitate this sort of thinking straight away. When it comes to my future practice, I am going to try and make sure that computational thinking is encouraged throughout my teaching. Wing says that computational thinking involves solving problems, designing systems, and understanding human behavior by drawing on the concepts fundamental to computer science. As a result, I think that a great way to start thinking about this is to find out the very basics of how computers work. As well as being a basis to their thinking, this sort of knowledge will always be convenient in the future. Once they gain an understanding of computers and the internet, the logics and systems used within them can be applied to other subjects to help children solve problems in a computational manner. Computational thinking, though once you know about it isn't the hardest thing to teach about, will be daunting for current teachers, so an introductory course into teaching children how to think like this would be very useful. When learning about this, one thing which the teachers would be taught about is the act of putting it in context. This involves incorporating computational thinking with other subjects, but also, when using programs like Scratch, the children should be given a task on there which will contribute to something bigger, to give them motivation to get them into it. Berry reinforces this, saying that programming projects should be meaningful and interesting.